5G systems, let us just recall a short recall about the various mobile generation that was before. And it started with 1G, and it is purely the analog systems, and the primary requirement is only the phone calls, and the type of multiple access scheme is FDMA. And after that, the next generation is 2G, and the facility offered is phone calls along with SMS, and it's complete digital systems, and the multiple access scheme was TDMA. And the updated version of 2G, we call it as a 2.5. Then it's facility offered is an add-on of internet that we call it as a GPRS. And after that, it's the updated version. What we are using the 2G technology now, we call it as a H technology. That is the enhanced version of the GPRS. And after that, it's 3G, and we call it as a CDMA 2000, as the multiple access technique used in the 3G is core division multiple access, and the key differentiator in 3G is somewhat a better internet experience when compared to the previous generation. And after that, it's updated to the HSPA 3G, that is, we call it as a high-speed packet access, and the differentiator is broadband internet and applications, and the speed will be in the range of around somewhat 7 to 8 Mbps. And the 3G is not that much successful. The hype, what we expected from 3G, is not matching with the real-time performance. And after that, the transition happened to 4G. That will created the very major change in the mobile phone industries, because the latency and what we are getting in 4G, and the speed of internet, what we are getting in 4G system is much better when compared to the previous generation. And technology what we are using in 4G is MIMO systems, MIMO based OFDM orthogonal frequency division multiple access, along with the concept of MIMO, MIMO. That is multiple antennas at the transmitter and receiver side. And whatever the requirement, what we need now, that we are getting in 4G, but anyway, there's no any endpoint for the technology. So whatever the speed and bandwidth we are getting, and we need more speed and more bandwidth. So we are going to switch over to the somewhat the next generation. We call it as a 5G, and the basic thing what we get in 5G is somewhat the better, very high speed internet connectivity and ultra low latency systems. This is the basic definition for 5G. That is one view we can say it as a hyper connected vision, and another one we call it as a next generation radio access technology. That is some applications need the high data rate and ultra low latency. For those kind of certain applications, we need to find out some more the next generation that satisfies those kind of applications. And the driving force for 5G is explosive growth in demand for the internet. As we discussed that, even though whatever the speed we are getting, we are not satisfied that speed and that bandwidth. So we need a more amount of speed, because the apps and the applications what we are using nowadays is very wide. For each and everything, we are using the mobile applications, and previously 3 or 4 years back, the number of connected devices is very minimum. So even though we have the Wi-Fi hotspot in our home, the mostly we can connect our mobile phones or laptops. But nowadays we can take each and every equipment in our home is converted as a smart equipment. So each and every device like television, air conditioner, refrigerator, washing machine, ovens, everything is connected to the internet. We can able to control those kind of application by using the mobile app. So the primary application, common thing we can call it as a IoT. So we need to control the more number of devices and larger number of connected devices. So we need somewhat high bandwidth. Those bandwidth is not sufficient in the 4G spectrum. So we need to go for higher spectrum. So we need to go for the different generation to satisfy those requirements. And to achieve these objectives, the 5G systems will provide the extreme broadband speed and ultra low latency and ultra reliable connectivity. These are the three basic requirements on why we need to move to 5G when then 4G. And this is the key capabilities, that is the comparison of 5G and 4G standards. That is IMT 2020 is nothing but 5G, and IMT advanced is 4G. If I take compare in terms of data rate, the speed guaranteed offered in 5G is almost 100 Mbps per second, 100 Mbps, and for 4G it is 10 Mbps. That is 10 times higher when compared to the 4G system. And the spectrum efficiency is 3 times higher when compared to 4G. And the mobility is 500 kilometer per hour, but in 4G it is only 350. And a very important thing, latency. The end-to-end latency of the 5G system is 1 milliseconds, but in 4G is 10 milliseconds. And the number of connected devices, the density will be 10 power 6, and efficiency will be 100 times better when compared to 4G. And traffic capacity is 10 Mbps per square meter. That is almost only 0.1 in terms of the 4G systems. So when comparing with all these aspects, the 5G outperforms when compared to the previous mobile generation. And the key usage scenarios for 5G is, as we discussed, the first requirement is high-speed mobile broadband. So nowadays, the applications what we are using nowadays needs very high-speed internet. And nowadays, everything, the televisions, the DTH system is somewhat rolled out, and everything we are using as a smart TV, and we are using a lot of OTT applications. And the content what provided in the OTT application is now it's 4K, and some of the service provider is offering the content in 8, even in 8K, and the applications like a VR, AR, these kind of application needs the internet that offers extreme bandwidth and extreme speed. As the 4G requirement, 4G is network is not enough to satisfy this requirement. We need to switch on to 5G for these kind of applications. And next one is a massive machine type communication. It's somewhat the industrial oriented. It's not the end user side kind of industrial IoT and industry 4.0 and massive machine to machine communication. For those kind of applications, we need the 5G systems. And next thing, ultra reliable and low latency for the applications like vehicle to vehicle communication and vehicle to infra communication, and some of the applications like autonomous driving. And these kind of application, we cannot able to compromise the latency. For example, the OTT application and online gaming or AR, VR application, we can able to compromise with the latency. That is not going to create any major impact. But the application like vehicle to vehicle communication and autonomous driving, we cannot able to compromise with the latency, and we need the system that provides very, very ultra low latency. For these kind of applications, we need to think about the 5G system, as the 4G systems cannot able to provide those kind of latency requirement. And in terms of usage scenario wise, the parameters like data rate and spectrum efficiency, capacity, network energy efficiency, mobility, those parameters is required for the updated enhanced mobile broadband. And connection density, it offers better in 5G, which can be used for massive machine type communications. And important thing, latency can able to use to construct the ultra reliable and ultra low latency communication system. So the basic 5G requirement summary, it will support new use cases and large number of connected devices and end-to-end latency of 1 millisecond and very high bandwidth, energy efficiency. These are some requirements of the 5G systems. And next we can see about the key component to construct the 5G systems. Okay, the 5 basic components to establish or to construct the 5G system is a millimeter wave and a small cells, massive MIMO, beamforming, and full duplex. If I want to realize a proper 5G system, I need to properly construct these 5 components. So these 5 components is, we call it as a 5 pillars for the 5G system that is going to support a proper 5G network. And before going to discuss about the each components, let us have the basic thing, that is the Shannon information capacity theorem. That is the maximum capacity that we can transmit to the channel is depends upon the bandwidth and the signal to noise ratio. That is a B is capacity is equal to B log base 2 of 1 plus SNR. Now these five building blocks is going to support this channel capacity theorem, which is going to help to improve the bandwidth performance and also to improve the signal to noise ratio in order to achieve the high capacity 5G network. And first we can start with the millimeter wave. And the reason why we need to go for millimeter wave, the spectrum, what is already used for applications like AM, FM, TV, and mobile phones, that is 1G, 2G, 3G, 4G, is already highly populated. So as the basic requirement of 5G is we need the extreme bandwidth and we have the more number of connected devices. As the spectrum, which is up to 6 GHz, is already highly populated. As we are going to 5G, we cannot able to insert or we cannot able to fix within that uh, populated spectrum. So we need to extend the spectral range from above 6 GHz, because the spectral range that is above 6 GHz is almost empty. There is no any applications using those spectral range. So for the 5G system, it is proposed to go with the spectral range of above 6 GHz and up to 300 GHz. As these unused spectrums, we can able to use it for the 5G network. So the basic requirements of 5G like high bandwidth and more number of connected devices can be achieved by using this unused spectral range. If I go for the spectral range, my waves will become the wavelength in terms of millimeters. So we call it as a millimeter wave. So to establish the 5G network, the basic requirements is to increase the spectral range, and we need to enter into the millimeter wave range. So as we enter into the millimeter wave range, as we are increasing the spectral range, we get the huge amount of bandwidth so that we can able to increase the capacity. So by implementing the concept of a millimeter wave, the 5G system will help us to increase the capacity by the way of increasing the bandwidth of the channel. And next thing, challenges in implementing the millimeter wave. As the primary concept of the communication system is, as we increase the frequency, the propagation distance is highly limited. But for the 5G systems, to get the better bandwidth and to accommodate more number of devices, we are increasing the spectral range and we are entering into the millimeter wave range. As we enter into the millimeter range, the problem is the propagation distance is highly limited, as the 5G signals cannot able to propagate into the concrete walls, or if we go into the shopping malls, the signals cannot able to enter into the basements, and the signal is highly attenuated due to the rain and fog and other atmospheric conditions, because as the frequency range is very high. That is one of the drawback of what we can see is if we enter into the millimeter wave range, but there is no any other option, as we want to get the better bandwidth and we need to accommodate more number of devices. The only option is the millimeter wave. Now we are going into the another technology to overcome the drawback of the millimeter wave. That is the next component. What we are using in the 5G system is a small cells. So the small cells primary purpose is to overcome the drawback by using the millimeter wave. As we use the millimeter wave, we have the lot of advantages, as it is the first pillar for or key component of implementing the 5G system. But it contains the drawback also. As to overcome the drawback, we are including the second component that we call it as a small cells. So the concept of a small cell is instead of using a single high power base station, we need to use the small number of miniaturized base stations. As the problem with the 5G system is a millimeter wave is short propagating distance. So the base stations, if you use the high power base stations like what we are using in previous mobile generation, the propagation distance is highly limited, and the waves will get attenuated by the buildings and other atmospheric conditions. So what we are going to do in 5G to overcome the drawback of the millimeter wave usage, instead of using hyper base station, we are going to use the miniatures base stations. We call it as a small cells. As this miniatures base station, the coverage area is limited, but within that area, it can able to provide the better network connectivity. So we can able to solve what is the drawback we are using the drawback we are getting while using the millimeter wave. So the unique features of using the small cells in 5G network is small sized antenna and targeted and efficient use of spectrum and spectral reuse. Now, uh, uh, the basic requirement to achieve the 5G, we need to go with the millimeter wave. Now, whatever the problems we are facing with the millimeter wave, we can able to overcome by using the concept of small cells. So, by the way, using both the key components like millimeter wave along with the small cells, we can able to increase the bandwidth. By the way, we can able to increase the signal to noise ratio. So, as we are increasing these two parameters simultaneously, we can able to increase the capacity of the channel, which is one of the key requirement in the 5G systems. And still, there's some challenges in implementing the small cell because even if we take any kind of systems or technologies, it contains the drawbacks as well as advantages as well as the drawback. So the key challenges in implementing the small cells is rural areas. For urban areas, we can able to implement the miniatures the base station. Even it is some countries they are proposing the base stations, fixing the base stations even in the street lights. Okay, but in case of rural areas, it is a key challenging to implement these kind of small cell networks, and the number of small cell networks required to get the proper coverage is in a huge number. This is challenges what we face if we go for the implementation of the small cell networks. And next key component in implementing the 5G system is a massive MIMO network. So if I use a millimeter wave, I will get the wide spectrum, and whatever the drawback I can face by using the millimeter wave, I can able to resolve by using the smart cells. Now, next thing I can see about the next key component of the 5G system is a massive MIMO. So this MIMO concept we have already used in the 4G system, that is the multiple antennas and the transmitter and receiver. As we are using the multiple antennas, we can able to achieve the spatial diversity and we can able to increase the data rate of the network. But in 5G, the speed requirement is high when compared to the 4G. So we need to go with the concept of the massive MIMO. That is more number of antennas in terms of hundreds of antennas arrays we are going to use it in the base station. So in MIMO concept, instead of multiple antennas, as we are using hundreds of antennas, so the concept of massive MIMO comes into the picture. This concept of massive MIMO is mandatory to achieve the speed to satisfy the speed requirement of the 5G network. So as we are increasing the number of antennas and antenna capacity, we can able to increase the bandwidth. By the way, it will support the Shannon capacity theorem to increase the capacity of the channel. So all these techniques that a millimeter wave and small cells and a massive MIMO is always try to improve the two parameters of bandwidth and signal to noise ratio. Now, this massive MIMO concept will help us to increase the bandwidth of the channel so that we can able to increase the channel capacity, which is one of the primary requirement of the 5G systems. Now, the challenge. So, if we go for millimeter wave, there will be a challenge. If I go for small cell, there will be a challenge. And similarly, if I go for the massive MIMO, I will get the better bandwidth. But the challenge is interference. As we are using hundreds of antenna arrays in the base stations, definitely there will be the chances of getting the interference among the antennas. As the antennas are closely spaced, there is a high probability of getting the interference if we go with the massive MIMO concept. As if I'm getting the interference, it leads to the increase of the noise power, so it leads to the impact in the signal to noise ratio. As it is reducing the signal to noise ratio, by the way, it is going to affect the capacity of the channel. So if I go with the massive MIMO concept, it will push the bandwidth so that I can able to increase the capacity. Also, it will try to reduce the SNR, so it will try to reduce the channel capacity. So it will the massive MIMO concept will try to balance between the bandwidth and SNR, so that the improvement of what we are getting by using the massive MIMO is not it's become useless. So we cannot able to ignore the concept of massive MIMO, because then only we can able to achieve increase the bandwidth and we can able to achieve the data rate. So and we need to find out the solution to overcome to resolve the drawback what we are using what we are getting while using the concept of massive MIMO. And the next key component, we call it as a beamforming. So this beamforming is a another component in the 5G to overcome the drawback what we are getting in the massive MIMO systems. So the massive MIMO systems, as the antennas are closely spaced and we are using the huge number of antenna, there is a chances for internet. But this concept of beamforming, instead of transmitting the signal in entire 360-degree entire wide area, it will focus the beams only to the corresponding user. So instead of transmitting the signal in a entire direction, it will focus and then the beam will be focused only to the corresponding user. So as it is focused only to the respective user, we can able to avoid the chances of getting the interference, even though we are using the concept of a massive MIMO. So if I want to use the massive MIMO, I cannot able to use it individually. I want to implement the massive MIMO along with the beamforming, so that the beamforming can handle the drawbacks what we are getting by using the concept of massive MIMO. And it is a short video about the concept of beamforming. So here, by using the concept of beamforming, we can see that the signals will be targeted only to the specific user. So even though if I use the massive number of antennas, we can able to avoid the chances of getting interference. So this is an example for how the beamforming can able to help us to reduce the interference that is caused by using the massive MIMO concept. Now, by using the concept of massive MIMO, we can able to reduce the interference power, so that we can able to increase the signal to noise ratio. So the massive MIMO will try to help us to improve the bandwidth, and this beamforming concept will try to reduce the interference by using massive MIMO, and it will try to avoid the reduction in the signal to noise ratio. So that by using the massive MIMO and beamforming as a combined parameter, combined component, they can able to increase the capacity of the channel, so that we can able to achieve the requirement of the 5G systems. And next thing, final one is here, full duplex communication. So the full duplex communication is not the new one. And the previous generations also, we are using the full duplex communication. But here in 5G system, the full duplex communication is somewhat a kind of a different thing. So in the previous generation, they use the different frequencies, meaning that different channels for achieving the full duplex. So one is for the uplink and one is for the downlink. We use the two spectral bands, that is the two different channels. But in case of this is the scenario, what is the full duplex systems we are using in a previous kind of mobile generation for uplink. If we use the same channel for both uplink and downlink, the signals will collide, and it's the purpose of communication is getting spoiled. So what we can use. We need to send one signal and other signals need to wait, and then we need to send other signals. This is a kind of thing happening in the off duplex systems. So off duplex, we cannot able to transmit, do uplink and downlink simultaneously. We need to do the uplink and then we need to wait and then we need to to the downlink process. But in case of full duplex, we use the two channels. One is for the uplink and one is for the downlink. That is, we use the two different frequencies for the uplink and downlink purpose. This is how the full duplex system works in the previous mobile generations. But in case of 5G, we use the same frequency, and to avoid the interference, we are going to use the concept of high-speed switching transistors. So these high-speed transistors will help us to switch over the signals, that is the signals coming in uplink and the signals going in downlink will get switch over by using these transistors, and we can able to avoid the interference between the two signals. So in 5G systems, to achieving the full duplexing is not required to use the two separate channels for uplink and downlink. By using the single frequency, we can able to do the uplink and downlink simultaneously without any interference by using the concept of these full switching transistors. So as we are using this concept, we can combine the both the channels. Instead of allocating the separate channel for our uplink and downlink, the two channels can be simultaneously used for uplink and downlink, so that we can able to increase the bandwidth of the transmission systems. So by using these concept of full duplexing, we can able to increase the bandwidth, and by the way, we can able to increase the capacity of the systems. So these are the five key components to achieve the 5G requirement, that is massive millimeter wave, and to avoid the drawback in millimeter wave, we need to go with the small cells, and then implementation of the massive MIMO concept to maximize the bandwidth, and to overcome the drawback of the massive MIMO, we need to go with the concept of beamforming, which will reduce the interference. By the way, it will increase the signal to noise ratio, and finally full duplexing. By using these five key components and five pillars, we can able to construct the proper 5G network. And all these key components will always try to achieve the Shannon capacity theorem, that is to increase to maximize the capacity of the network by the way of increasing the bandwidth and signal to noise ratio. This is about the key components that what we are using in 5G network. And next we can move on to the optical part. So far we have discussed about the wireless part, how these wireless system concepts can be used in modern communication system. And next we can see the role of optics. As we told that if we talk about the modern communication systems, it's not like that only we can talk about communication. So definitely there will be a role of optics, and most of the updated system what we are using nowadays is a kind of hybrid systems. So it's not only purely wireless based, and it's not purely optical based. It is a combination of wireless and optics that we call it as a hybrid. Because whatever the application we are using nowadays, it needs the support of the wireless technologies as well as the optical technologies. And the major advantage going with the optics is the bandwidth. And the major drawback in the wireless systems is bandwidth. Those drawbacks can be addressed by using the optical system, because the frequency what we are using for the optics is higher when compared to the wireless system, as we can able to achieve the huge bandwidth. So these optical systems also will be classified as wired and wireless, because if we talk about the previous nearly a decade back, there is no the concept of wireless in optics. So it is purely the wired fiber-based communication, and there is no any we don't get the advantage of mobility. But nowadays the concept of wireless even comes into the optics also, and we can use the wireless optic scenario in indoor, we call it as a visible light communication, and outdoor we call it as a free space optical communication, we call it as a FSO. So the FSO is not commercially practically implemented, but the concept of indoor wireless optics is used. Even some of the devices in mobile phone, the Samsung phones introduce these uh, wireless optics concept for doing the data transfer. So this is the electromagnetic spectrum as we discussed that the spectral bands what we are using for communication applications like AM, FM, and television, and microwave band is used for the mobile communication. In the microwave band, the enhanced band what we are using for the 5G network. And if we cross the millimeter band and we can enter into the IR and visible. So these IR and visible, we call it as a light bands. These bands can be used for the purpose of optical communication system. So in these bands, the frequency range will be in terms of terahertz. As the wireless system supports only the gigahertz bands, these terahertz bands not able to propagate in open space, and we need the guided media. But the advantage what we get in these spectral bands is a kind of huge, virtually unlimited bandwidth. That's why the optics major strength is about the bandwidth. And in our home, even though we are using the mobile phones, we don't rely on the mobile speed in most of the times. So as we discussed that in the now every appliance in our home is converted as a smart, and television is converted as a smart TVs, and we have OTT application that can provide the content in terms of 4K and 8K. But those contents we cannot able to stream by using the internet speeds what we are getting in the wireless. So obviously we need to go for the fiber broadband kind of things as we get the stable and a high speed internet to satisfy those requirements. And that is a major key differentiator in the optics. Generally, in the optics, if you take it as a fiber broadband, the price what we are paying in terms of speed. But if you take it in your mobile communication, the recharge or what the price, the billing, what you are going to pay in terms of the data usage. So even though if you are willing to pay more amount, the service provider cannot able to offer you the plan in terms of the speed, because in the wireless communication the bandwidth is somewhat limited. The mobile companies spending the major of its money to the spectrum only, as the spectrum is somewhat too much costlier and it is limited. The mobile service provider cannot able to promise the constant speed at all the times. That's why they are not selling the plans in terms of speed. They are always giving the customers their plans in terms of the data usage. So there's a data takes of 2 GB per day or 3 GB per day, and they're not ready to offer you the fixed speed with unlimited data, because that's a crucial uh, thing in the bandwidth. And during the peak hours, if there is more number of users, and even though you have not exceeded the fair usage policy, your bandwidth will got somewhat limited. And those kind of bandwidth issues is completely resolved if we go with the optical solutions, because as we are using the light carrier, the frequency is in terms of terahertz. So it's ready to offer the huge bandwidth. Nowadays, we are getting the speed even in terms of 1 GB Gbps in the fiber broadband. That 1 Gbps will be provided 24/7, even though if there is a peak hours or whatever it is, we get the promise constant speed in the optical network. So it is just about the comparison of the wireless systems, optical systems, and the wireless optic systems. We call it as a free space optics. In wireless communication systems, the bandwidth usually will be in terms of gigahertz. That's why, as we told, that certain applications uh, we can able to satisfy by using these gigahertz bandwidth. So we need to combine that uh, optics along with wireless, and we need to go for the hybrid systems so that we can able to increase the bandwidth to terahertz applications, so that the application like online gaming, AR, VR, and 8K content can be streamed by using this terahertz bandwidth. In terms of data rate wise, as the bandwidth is limited, so it obviously going to impact your data rate. But in terms of optics, the speed is very, very high. And a wireless system requires the license, and the optic system are license free, and lifetime maintenance is free for wireless optics as well as the wireless RF, but fiber-based systems need the periodic maintenance because as we are using the physical cable, so it needs the periodic maintenance, and lifetime of the wireless system is short, and it's long duration for the optical systems. And cost-wise, if you go for the wireless optics, it's low. But if you go for the wired optics, it's expensive because the cost of the fibers is somewhat high, and we need to bear the installation cost. The creating the facilities will be somewhat expensive, and as well as the installation wise, it's somewhat difficult in terms of the wired optics as we need to lay the fiber cables. But these wireless systems and wireless optics is a kind of free space. The installation process is somewhat easy. And this is about somewhat the zigzag comparison about of the uh, wired and optical systems. If my channel is free space and if my signal is RF signal, that we call it as a traditional mobile systems, that is a wireless communication system. And even we can able to transmit the RF in fiber cable. That technology we call it as a radio fiber systems. And if I transmit the light signal in the fiber-based cable, that we call it a traditional fiber optic communication system. And if my channel is a free space and my signal is a light signal, that we call it as a wireless optics. That is a free space optical communication. So depends upon the channel, and depends upon what are the type of signal you are going to take. In any combination, we can mix it and we can make it as a somewhat called a hybrid communication system. As we discussed that, the major applications what we are using now is not completely satisfied by optics, or is not completely satisfied by wireless, and we need to go up for the mixing hybrid kind of systems for to satisfy the to achieve the modern wireless communications, modern communication system. And let us see the key components. So as the session suggests that we are going to see about what are the key components required to establish the wireless optics. So we have discussed about the key component required for the wireless RF. That is, we have taken the example of the 5G systems, and we have discussed about what are the key components required for constructing the 5G systems. And similarly, if we take the wireless optics, the key components in terms of hardware wise, that key component required. First thing, we need to have a optical modulator circuit, modulator. So as we have optical modulator, we need to take the message and we need to take the optical carrier and we need to modulate the carrier based on the input message. And the most common modulation format what we use in optics is the over K on off key. So after modulation, then we need to apply to the driver circuit, and then it is given to the optical source, and then it is given to the transmitter lens. So here at the transmitter side, depends upon the requirement, that is the transmission distance. We can go with the option of the internal modulation or external modulation. In case of internal modulation, the message signal is directly applied to the optical source, and the source will do the modulation by itself. And if it is a high-end system and somewhat you are going for the long-haul communication, we need to go with the option of the external modulator, that is carrier signal, and the message signal is applied to the external modulator. That modulator will do the modulation process. If I go with the concept of external modulation, I will get high stability, and that is suitable for the long haul distance. Even the signals can able to propagate up to thousands of kilometers. But it's only the long haul system. The propagation distance is somewhat less than a few kilometers. Means then the better option is to go with the internal modulation, because the internal modulator will be the cost-effective solution. So in the short haul, we can go with the external modulator. There is no issue with that, but cost-wise, it will cost you high. So for the cost-effective solution and a simple transmitter model, the better option is to go with the internal modulators, internal modulation process. And in wireless optics, the major issue happens at the channel part. And as we are going to transmit the light signal in free space, the signal will get highly affected by the atmospheric effects like absorption, turbulence, scattering, the scintillation effects. These atmospheric effects is going to play the major role while designing the optical wireless systems. So transmitter and receiver part is somewhat not going to give them much trouble. And a major issue what we can face if we go for the wireless optics is in the channel part. As in a fiber-based communication, optical communication, the channel part is stress-free because it is a guided medium. It is a physical wired channel. The channel is not going to create any major impact. But it is a reverse case. If I go for the wireless optics, as it is an open space, the signal will get highly activated by using a lot of channel issues, channel parameters. Now, the advantage of going these kind of optical solution, wireless optical solution, it's absolutely safe. As it is true or not, if you go for talk about the wireless system and uh, people think about that it can be a harmful radiation, but these optics light signal is as it is a light signal is no way going to create any harmful reactions. It's perfectly safe for transmitting in the free space, and it's highly secure. Even when compared to the wireless or wireless, these kind of optical solutions are highly secure. And one more thing, interference. These optical signals are completely interference free. And one of the major issue what we can face in the wireless system, as we discussed, that if we go for the massive MIMO concept, we are getting a higher amount of interference. To overcome that interference, we are going for the beamforming. Those kind of interference is completely discarded if we go for the optical based solutions and high speed. Now, even though it contains the advantages, there is challenges we can face in uh, optical solution, that is the connectivity. And mostly if you go for the optical solution, we need the LOS connectivity. There is no any reflected spectrum and reflected thing will happen in the optics kind of multipath propagation. What we are getting in wireless communication, those kind of multipath propagation is not feasible in optical solution, as we always need the line of sight connectivity. And multi-user support, dimming, shadowing, and these kind of challenges we face if we go for the optics-based solution for realizing the modern communication system. And then application-wise, it is a last mile access. That is, even if we take now present mobile communication systems, the backhaul connectivity is purely fiber-based. So we are using the from front or mobile to base station will be the RF, and fiber to base station to switching center, and base station to BS connectivity is completely based on the optics, because uh, data rate reliability. The reliability of the optical network is not what we are getting in the wireless networks. So uh, the major application is backup for the backhaul links, that what we are using in a mobile network, and the disaster recovery. These FSO networks that we can use it as a temporary links. And it can be during the disaster times, it can be used as a ad hoc networks, because the implementation wise, it's a very easy thing to install. So we can take one FSO transmitter and we can install the FSO receiver, and installation process is quite simple. So we can able to use this as a concept of ad hoc networks. And then cellular communication backhaul. So the backhaul, nowadays we are using the fiber-based backhaul. As the distance is limited and if the technology supports, even we can use the SSO based solution as a backhaul. So BS to BS connectivity instead of the fiber cables, we can try with the FSO, and currently it's not supported. It's under some more testing under research, because as we discussed that the channel impairment is the attenuation and atmospheric conditions is a major drawback for the FSO signal transmission. Next, the challenges, as we already discussed, that the major challenge is the atmospheric attenuation, kind of absorption, scattering, and turbulence, scintillation. These kind of major impact of what we can see is if we transmit the optical signal in a free space. As it contains the advantage like easy to implement, and we get the huge amount of data rate, but still we can face these kind of atmospheric attenuation. That's why the FSO system, the major drawback what we can face is a limited coverage. So if the technology improvement happens and we can able to tackle these kind of atmospheric attenuations, and in future mostly the fiber links can be replaced with the FSO systems, that it can offer better performance when compared with the fiber links as well as in the other wireless systems. This is some more the example of hybrid communication. So in this hybrid communication, we have the FSO connectivity, and we have the RF, and we have the RYF also, that is the radio fiber systems. And we can see it's from building to base station, the backbone what we are using as a fiber based backbone. Okay, backhaul network is a fiber based, and the end mobile user, the front all will be the RF based, and building to building connectivity, it's the FSO network. So we are using the fiber network, and we are using the FSO system, and we are using the conventional RF system. So building to building, we can able to transmit the data using the FSO transceivers at the top of the building. We can place the FSO transceivers, and we can able to easily establish the LOS connectivity, and we can able to transmit the data. And base station to building, and we can able to use the fiber cables as a backhaul network, and as an end user, we can able to use the Wi-Fi access, that is the wireless communication RF access. So this, if you want to go with these kind of modernization, and to satisfy the requirement of what we need to get in the now advanced thing, and we need to think about in the way of kind of hybrid mixing network. So in this kind of scenario, if I rely on only wireless, I cannot able to match with my requirement, and if I rely on only optics, I cannot able to match with my network. So I need to mix both optics, wireless, and wireless optics in a hybrid way, so that the requirement what we need now can be achieved by using these kind of hybrid communication. And this is somewhat just an example of about the role of free space. Nowadays, we are using the Wi-Fi hotspots to get the Wi-Fi connectivity. But in future, these LED lamps, LED lights, what we are using in home nowadays, can be used as a smart LEDs, and these smart LEDs can be act as a hotspot, and we call it as a Wi-Fi hotspots. So the advantage of what we get in Wi-Fi hotspot is speed. So even we are getting the speed in terms of the Gbps. That is not possible by the Wi-Fi hotspots. Whatever the routers, the access point, what we are using nowadays will offer the maximum speed of around Gbps. But if we go for this kind of Wi-Fi hotspot, even we can able to realize the speed in terms of terabits per second. Okay, that is the power of optics. We can merge with wireless networks along with optics, and we can replace the normal access point with the Wi-Fi access point, so that we can able to get the speed in terms of that TBPS. That even in the future, technologies can able to satisfy with these kind of speed. In future, we can upgrade to 8K or 16K or whatever it is. Those kind of high data rate application can be easily tackled by those kind of smart LED, that is SSO techniques. And this one. And in wireless communication and 5G, and we are thinking about the small cells. So instead of using the high power base station, we can use the miniature base station. But in case of if the same thing that we can come into the optics into picture, even these street lamps we can replace with the smart LED lamps, and we can make each and every street lamp as a access points. So only thing is, futuristic thinking, the concept of base stations can be revoked, and these street lamps can be used as access points, and they can able to provide the internet coverage. And vehicle to vehicle communication, as we discussed that one of the key requirement, key use case of the 5G is vehicle to vehicle communication and autonomous driving. Now these vehicle to vehicle communication, the major drawback is what we need is ultra low latency. Those kind of latency requirement can be easily handled if we put the optics into the picture. That is, even the car headlamps can be replaced by the smart LED lamps, and that LED lamps, headlights, we can able to make it as a hotspot. So those car headlights we can able to convert to the Wi-Fi hotspots, and we can able to establish the connectivity between the vehicles. Those connectivity can be reliable, as well as it can be very less in latency, and also it provides the very high broadband connectivity. So it can be a single solution for multiple problems. And this is one of the practical thing that is tested one. The data connectivity between the two laptops can be done by using the SSO transceiver. Okay, and as I uh, told that the Samsung smartphones had tried with these SSO transceivers. So from mobile phone data transfer, instead of using the Bluetooth or Wi-Fi, they have tried with the SSO transmitters. The advantage what we get in SSO transceivers is the speed is in terms of Tbps. So just imagine that even the content of a laptop can be entirely transmitted to another one laptop within a seconds. Okay, that is the power of optics. These even we can't able to imagine in case of wireless system, as the bandwidth is one of the major drawback in wireless systems. So if I merge that wireless with the optical solution, so the bandwidth issue can be resolved, and I can able to realize the modern communication systems. So it is a summary of my session. That is, we have started with the wireless thing and 5G, and we have discussed about what is the key component for the 5G, and to overcome the drawback what we are facing in the normal wireless system. At that place, we can implement the optical solutions so that we can able to overcome the drawback in wireless, and we can able to realize the exact modern communication system that can satisfy the applications and requirements what we need now. And that's about my presentation. And thank you for listening. And if there is any queries, I'm happy to answer it. Any questions or any queries?
Participants, any queries?
If there is no queries, then we can close up with the session, I think.
Participants, any queries? Sir, in your slides, you have discussed with some real-time example now, sir.
Yes,
For
ma'am.
communication. Sir, is there any tool that we can work out on this related to vehicle area network, sir?
And are you asking about the simulation tool, ma'am?
Yes, sir.
And the simulation tool, the general thing and common to open to all is a MATLAB. That everything we can do it as a mathematical modeling only. But real-time implementation is not currently possible in our end, only in the simulation modeling. And in case of wireless, we can go with a MATLAB. And if you want to do with the simulation concepts in optics, there's a simulations tool like Opti system and virtual photonics. Those are the tools will provide the better support for doing these kind of simulation. And even if you go for the tools like virtual photonics and optic system, and you can able to merge that tool with the MATLAB. Okay, and whatever the concepts you want to execute in a wireless scenario, that you can able to write it as a MATLAB code, and those codes you can embed with that VPA tool or optic system, and you can able to create the core simulation.
Okay.
So it's not possible with single tool, and you need to merge one or two.
Thank you, sir. Okay, sir. Any queries, participants? So that we can conclude, sir.
Okay.
Dear sir, on behalf of our institution and organization team, I would like to extend our sincere gratitude for your insightful session on modern wireless communication system components and wireless and optics. Your expertise and clear explanations not only deepened our understanding of the subject, but also sparked meaningful discussions among participants. The way you connected theoretical concepts with real-time applications made the session truly engaging and impactful. We greatly appreciate the time and effort you dedicated to share your knowledge with us. Your contribution has enriched our learning experience and will help us in our future endeavors in the field of wireless communication. Thank you once again, sir, for your valuable presence and guidance.
And thank you for inviting, and thank you, participant, for the patient listening for the past 1 hour. And thank you, ma'am. Have a
Thank
good
you.
day.
Thank you, sir. You too have a good day, sir. Dear participants, kindly post the attendance and feedback. The link will be presented in your chat box. Dear participants, kindly stay connected in the meet. We can start the next session by 7:35 p.m. Thank you all. Kindly post the attendance and feedback using the link given in the chat box. Thank you.